Alright, so the fan clutch stopped working on my 18-wheeler, and it's run off the computer on the side of the motor, the ECM. And what happened was it burnt the solenoid up because it was telling the solenoid to stay hot at all times, the signal from the ECM. And what I found out through research and testing, the ECM has contacts in there that are known to burn up from time to time on those trucks. It's got a Cummins ISX motor, and it makes the fan clutch, not work. It burns up the solenoid. Well, I didn't know, and I bought the solenoid pack on the Volvo. It's got five solenoids on it. It works your differential lock, your fifth wheel slide, your suspension dump, your horn, and the fan clutch. And everything quit working. It burnt the wires where they plug up in. It's up on the truck, so I can't really show it. It's pretty much on top of the transmission where the solenoid block's mounted at. And it burned all that up. The horn started blowing going down the road. It was real nice. So I didn't know what was going on. But anyway, that's what I found to be the problem. Well, I put a new one of those solenoid packs. It's like a solenoid pack thing, then 5 individual solenoids on it. So I replaced just that solenoid pack, and I swapped the solenoid from my suspension dump over to my fan clutch because I don't use the suspension dump that much, and I can get by without it. The solenoids are $100 a piece or a little over, and the solenoid pack that they mount into is about $100. So anyway, I swapped that. Well, in testing and trying to figure it out, it burnt the second solenoid pack thing I put on there up. So I ordered a third one, but I never put it on there because I wanted to find out, what the problem was, to see what was going on with it. So I still got the third one, and I'm not going to put it on there right now. Dang fly. But anyway, they want like $1,500–$1,600 for the ECM. Plus it has to be programmed for the dealer, and everything else works good on it, other than the fan clutch there. So what I'm going to do is, I got this box of parts here I ordered up, and I'm going to try to convert this thing back to like the old trucks used to work, with a temperature switch sensor, and the thermostat housing, and an air conditioned pressure sensor. So what I've got here is I've got some 1/4-inch DOT airline. I ordered just a regular old style solenoid, fan clutch solenoid from Horton. That's Horton, they make fan clutches. And the way this system works, this fan clutch is spring engaged and air disengaged. So when there's no air going to it, the fan's locked on, and it kills your fuel mileage. They say these fans drive about 40 horsepower is what it takes to turn them when they're locked on. And it's making my fuel mileage, instead of be around a 5.89, what I usually get, it's about 4.8. So that line that goes into that solenoid pack that runs all those accessories I just named off, your suspension dump and everything, is a 3/8 line. So what I'm going to do is I'm going to cut that line in two, splice into it each way here. I'm going to come out of there with that 1/4-inch right here and go into this solenoid with a 1/4-inch. Come out of the other side with a 1/4-inch and go into the fan clutch with a 1/4-inch. And this is a normally closed solenoid, so that the air is blocked off. Normally, I'll have to apply voltage here to open the solenoid to allow air to disengage the fan. Alright, now I got this normally closed switch here. This is a pressure switch right here. This is normally closed switched here as well. This is the AC pressure switch. It comes with a little kit here. You can either cut the high pressure AC line and hose clamp this in there and that pressure sensor screw on there, or they send you this tap here that's got a spigot and a rubber seal on it, and you clamp this around your line, and this thing here, I don't know if you can see that, but it's got a tip on it right there, like a can tap, and you screw that on there, and then you screw your sensor onto that right there. So I should be able to do that. I think I can probably do that with Freon still in the system, like when you when you pierce a can of Freon with a can tap. So I think I'm going to try that and screw that in there that way. The other thing I got here is a temperature sensor right here, and this will screw in the water manifold. I'm not sure what thread's in the manifold. I may have to reduce this down or increase it or whatever. I'm not sure. I hadn't got there yet, but it's also normally closed. So with that being said, it being a normally closed, it should be that oh yeah, what was I saying? Okay, so these are normally closed switches, so they will pass voltage through this here. So voltage will be going to this solenoid at all times until either the temperature reaches 205 so this will pass voltage through. This is normally closed, this is normally closed. It's a normally closed solenoid. So being how these are normally closed switches, it will pass voltage through here to the solenoid to make this solenoid stay open until it reaches 205. Well, at 205, this temperature switch will open. Once it opens, that cuts the voltage to this solenoid, and this solenoid will close, and it cuts the air off to the fan clutch, which makes it spring engage. And this one here is the same way. It is normally closed until air conditioner pressure, high side pressure hits 300. When it hits 300, this switch will open, cutting the power to this solenoid, which will make it close, which will make the fan clutch spring engage because it cuts the air, and the air is what releases it. So I'm going to wire that up just like that. I've got about $200 in this right here. Actually, maybe a little less than that right now. This pressure sensor I actually found the guy had for sale. It was like an old stock part for $8, and it comes with a whole install kit. It's like a $60 part right there, or maybe $80. I'm not even sure. Could be $100 depending on where you buy it. But I give $8 for that on eBay. The guy had it, and I took a gamble on it. I didn't know if it was normally open or normally closed. It did not say. And normally closed is more common, but I took a gamble on it, and I figured for $8, I mean, that right there is worth $8, or that right there just for the fittings, and I could buy the sensor later if it wasn't right. But turned out it was correct. It's a normally closed. That'll work with the normally closed switch and the fan clutch and everything I got. The only issue that I could think of would be if the solenoid burns up, because it's staying engaged most of the time, because the fan's not going to be running most of the time. But that is how the factory one was wired. So that's the way I'm doing this one, and it's a fail safe doing it that way. So if the solenoid does fail or something in that circuit does fail, this being a normally closed solenoid, it will close and fail position and cut the air off to that fan clutch, meaning the fan will stay locked on because it's spring engaged. And that will keep the engine from burning up, running hot, burning up. So I could have went with a normally open setup, normally open switches, and my fan clutch would have been disengaged all the time until this reached 205, and then it would have applied cut the air off to the clutch and spring engaged it that way. But this is the way the factory system was with a normally closed solenoid. It was a different type of solenoid. It was a little bitty plastic solenoid that goes on that solenoid manifold. Wasn't near as heavy duty looking as this one is. But that's the way it was wired, and it was operated by the computer. The computer simply reads another temperature sensor that's in the manifold, and the AC pressure sensor that's in the AC line, and the computer tells the solenoid that was on there to do basically the same thing that these switches will tell it. And so this right here, if I can get all this and whatever, if I need some wires or switches or whatever else I need, but get all this on there for $200, versus buying a $1,500 or $1,600 ECM, that's the way I'm going to do it. I don't see nothing else wrong why I should do that when that's the only thing wrong with the computer at this time. So I'll add to this whenever I get to installing it here. Okay, so I've got my fitting out of my thermostat housing. I'll show you. It is right down in, well, there. You see where the water's coming out? That's the thermostat housing. This is a thermostat neck where it goes down there. So that's the bottom side of the thermostat housing. And it's an O-ring type thread. They didn't have one of those at the part house. This is the blank fitting that was in there, the plug. I didn't have an Allen wrench that size. I don't know what it is, about a 11 or 12 millimeter maybe. So I chiseled it out. It's got an O-ring with a straight thread. All they had was this pipe thread, bushing half to 3/4 pipe thread. The sensors are half, and that's the 3/4. They're really close, but obviously the pipe thread has a taper, but I should be able to put some tape on that and get it to seal. Like I say, I've done this before. I actually had to do it on my air fitting one time, and it leaked a little air, and I pulled it back out and put some JB Quick on it and tightened it back up, and it snugged up, and no problems ever since. So this should work fine for what I'm doing with it here on this water, because there's no pressure on the water other than about, I don't know, 10, 15 pounds or something. So I'm going to get this taped up and threaded together and stuck in there. Alright, I got the fitting all taped up, screwed together there with a temperature sensor. I can hold this camera and get it started down in the hole there. Well, this breather's in the way. Alright, I got the fitting all taped up there. As you can see, I'll try to get it started in the hole and hold the camera. This breather's all in the way, but should be able to get it done there. Can't really get a wrench on the big part, so I'm using the wrench on the sensor to actually snug it down. Pretty snug there. Hate to go much more than that. You can see right there where it's at, how I got it screwed in there and everything. I should be able to connect my two wires on top of it here, and should work. Alright YouTube, this is what plan B looks like. I know this is going to look a little bit hackish, but that's all the parts house had for me to try to put this back together so I can get my air conditioner back working. I don't have time to order another tap and deal with that, so they didn't have a fitting like this for a push hose, so I'm going to use this nipple here and shove it in there, put two hose clamps on it, and then put a piece of hose between this fitting here and that fitting, and then splice it with the other side. That's the best I can do for right now, so it'll have to work.